Okay, so hello, good afternoon. So I hope each one of you have already settled in for our YouTube live this afternoon. So will be our last online discussion for this semester, no? But before anything else, I will check your attendance first, no? Or record your own attendance by using this link, no? So we're just putting the link on our YouTube, no, chat box or live chat box, no. Okay. So it has already been posted on our YouTube live, no, chat box. Then once you click on the link, you will be required with a password. So the password for that one is also I will be also typing on the chat box, no? So that is the password. Okay, and for those of you who cannot see the chat box, I will be also typing the password on our group chat, no? Okay. Okay, so as of now, there are two, no, who are concurrently watching, four concurrently watching the stream. Okay. So you just check for some technicalities here, no. So we're typing some. Okay. Okay, so the password is this one, no? So I will just correct the password and send the wrong password. Okay. Okay. So there are four of you who are concurrently joining this live stream, no? So I guess some of you have already recorded their response or their attendance, no? So let's go directly to the discussion at hand, no? Because we will have few topics that we are going to discuss in this discussion, no? Okay. Okay, so now we will go directly to the topics that we are going to discuss. So the topics are, first we will be discussing about wire sizes and designation, then outlets and receptacles, switches, types of circuit breakers, and types of electrical lamps. Okay, so we'll go directly to wire sizes and designation. So wires or conductors are the pathway of the electrical current to move, no, from the source to the load, then going back to the source. So usually a complete circuit is a closed loop, and the link between the load and the source is the wires, no? Okay, so we have wire size indicates the overall cross-sectional area of a wire. So that is the cross-sectional area. So the shape of a wire is usually circular or a circle. So the wire size indicates the area of that circle. So that is the cross-sectional area. So in the English system, no, the sizes of wire is indicated by the AWG or the American Wire Gauge. So it is a designation of the wire sizes adopted by the National Electrical Code of the USA or the United States of America. So the sizes of the wires are expressed in circular mils, no, or MCM. Then in the SI unit system, no, so the metric system, so the metric system is the system that we are using, no, or we adopted as our standard for our electrical installations, no, or the practice of electrical engineering in the Philippines. So for the SI system, we uses the square millimeter or the mm squared, no. So we have the table of conversions for wire sizes. So these are the metric, no? This is the metric, and this is the American wire gauge and the diameter of the wire. So we have for 2.0, so that is square mm. Then for the American wire gauge, that is 14 AWG, no? 3.5 square mm, that is equivalent to number 12. So number 12 AWG. 5.5 square mm, that is 10, no? Number 10 AWG, and 8.0, that is 3.2, no? mm in diameter. The equivalent of that in American wire gauge is number 8, no? Up to, for this table, we have up to 100, no? 100 square mm, or we call that one as 40 or 4/0 or 000 AWG, no? So we'll now go to the types of wire according to wire insulation. So wire are often characterized by their insulation. So what is the purpose of having an insulation of wire? So aside from protecting the wire from damage, no, it is also used for also to avoid unintentional contact to the live or the hot wire or the hot conductor itself, no? So insulation is the skin of the wire that protects it from external damage due to changes in temperature and other factors. Because if the wire is heated or if the temperature inside a wire increase, so the resistance of the wire also increases. So if there is an increase in the resistance, so the wire also will get much hotter, and it will can cause fire or some other fault, no, on the electrical system. So wire insulation coding. So we have the coding for the wire insulation. So the naming of the wire, it depends on the coding of the wire insulation. So first we have the first letter, which indicates the type of the materials the insulation is made up. Second and the third letter, which is the third letter itself is optional, indicates the maximum temperature rating and the type of application it can be applied. Then the last letter, the fourth letter, which is also optional, indicates the additional protection added to the wire. Okay. Next is, we'll now go to an example of this one, no? Okay. Just check first if, okay, so it is already now indicated on our, okay. So we have here the example, no? This is an example of a wire. So this is the most common wire used in electrical installation in residential buildings. So we have the THHN. So the THHN, so it indicates, no? The first letter means thermoplastic material. So it is a material which can stand high temperature, no? The second and the third letter, so we have here the HH, so that is equivalent to 90 degrees Celsius. So this is the temperature rating, and also this wire also indicate, or the HH also indicates that the wire is applicable to dry and damp location. Then the fourth letter, which is N, meaning it is nylon coated, so it has a additional protection of a nylon or a plastic covering, which also protects the wire again from damage, no? So we'll now go to the individual meaning of the letters, no, on the wire coding. So first we have the first letter. So if it is T, it means thermoplastic, no? So thermoplastic is an insulation which is very common. It is like chocolate, no? It will soften and melt if heated above its rated temperature. It can be heated, melted, and reshaped. So thermoplastic insulation will stiffen. So stiffen at temperature colder than 14 degrees Fahrenheit or minus 10 degrees Celsius. So T stands for thermoplastic. So it is like chocolate, meaning it could be softened by heat, no? Or could be melted by heat. It could be reshaped, and also it could be stiffened, or it will harden, no? Harden and become brittle at the temperature colder than 40 degrees Fahrenheit or minus 10 degrees Celsius. Then we could have also for the first letter X or R. So X or R will mean thermoset. So thermoset insulation can withstand higher and lower temperature. So it is like baking a cake, no? So once the ingredients have been mixed, heated and formed, it can never be reshaped and reheated. So meaning a thermoplastic, once it is subjected to its above its rated temperature, then it will melt, or it could become brittle by itself, no? So that is the purpose of a thermoset. Then temperature rating, which is all about the second, third, and the fourth letter. So if your second letter is H, no, it indicates a maximum allowable temperature of 75 degrees Celsius. So if H, or there is no H present, no, so the maximum temperature is only 60 degrees Celsius. Then HH, or some of the electrician will call that one as double H, no? Some will say double heat, no, but it is, but sticking to the coding itself, it is just HH, no? It indicates a maximum allowable temperature of 90 degrees Celsius for dry and damp location. So meaning HH will indicate that the allowable temperature for the wire is 90 degrees Celsius, no? So if the wire, for example, the wire will be placed on an environment greater than 90 degrees Celsius, then that wire, then that insulation will fail. So meaning it could melt, or it could become brittle. So the application of this type of wire, which has HH on its naming, is for dry and damp location. So we have also HHW, indicates a maximum allowable temperature of 90 degrees Celsius. So for the HH, then the W, for example, it has a W. So for wet locations, it can be used on wet locations, but its maximum temperature rating, which will be only 75 degrees Celsius. Then we have also W, indicates the suitability for wet and dry location. So if a wire has a letter on it which is W, so meaning that wire could be used in wet and dry location. So later on the next few slides, we will also describe, no, or have the distinction between dry, damp, wet, and exposed location, no. Then N indicates a nylon sheeted around the thermoplastic insulation. Then dash 2, so if you have a dash 2, indicates the allowable temperature of the is 90 degrees Celsius, even if the wire is used or in wet or in dry location. Okay. So we have now here the types of location. Okay, so first we have the damp location. So locations protected from weather and not subject to saturation with water or other liquids, but subject to moderate degrees of moisture. So example of such locations include partially protected locations under canopies, marquees, roof, open porches, and like locations and interior locations subject to moderate degrees of moisture, such as basements, some barns, and some cold storage warehouse. So a damp location is a location which is not directly exposed to weather or any saturation of water or other liquids. So that is the damp location. But it doesn't mean that it could have moisture in itself, no? Because if it is protected from wetness or dampness, it will not be called as a dry location. So a location not normally subject to damp or wetness location, no? So a location classified as dry may be temporarily subject to dampness or wetness, as in the case of a building under construction. So for example, if a building has its ceiling, so the ceiling is considered as a dry location. But during the construction of a building, so meaning there is no walls, there is no proper roofing, so that the ceiling itself could be considered as still a dry location, but it is subject to dampness or weakness due to the lack of protection from weather. But we could not call that one as a damp location, no? Then wet location. So installations under the ground or in concrete slabs or masonry in direct contact with the earth. Location subject to saturation with water or other liquids such as vehicle washing areas. Location exposed to weather and unprotected, no? The interior of raceway installed in wet location is considered a wet location. Insulated conductors and cables in these locations are be listed for wet location. So a wet location is a location usually under the floor slab. So meaning if your floor slab is directly exposed to or directly above a ground or above the ground, so that is considered as a wet location. In another example is a garage, no, wherein the garage house, no, the garage is where the owner of the car will usually clean his car, or also outside, no. For example, we have a landscaping in which we will be using some lights. So the ground itself in which the wires have been installed, so it will be considered as wet location, no? Or location that, so for example, if that wire, no, so the wire is listed at THN/THWN, so it could be used in dry location, which will be considered as THHN, and also for wet location, which will be considered that wire as THWN. Okay? Next, we will go to wire ampacities. So what is an ampacity? So the ampacity is the ability of the wire to handle the current. So it is the rated current which the wire could handle. So first, we have this one here, the common wires used in electrical system installation. So we have the number 18 and 16, or 0.75 square mm and 1.2 square mm. So these wires are usually considered as fixture wire. So when we say fixtures wire, those wire that is used to connect auxiliary, the Wi-Fi itself, then the auxiliary lights. So usually the wires used for that one is 18 and 16. So the ampacity is 10 amperes, 13 amperes. Then we have the 14, so that is 2.0. So the strand of the wire is solid, so that is 15 amperes, no? And the highest for this list is the 6, no? Number 6 AWG, which is 14 square mm. It is stranded and it is rated. Now the ampacity is 50 amperes. Okay? Okay, now we will go to the next slide. So we have this one. So this is from the Philippine Electrical Code. So this is table 3.10.1.17, or the allowable ampacities of single insulated conductors rated 0 to 200 volts in free air. So meaning the wires are not installed or are not put inside the raceway or a conduit. So based on an ambient air temperature of 30 degrees Celsius. So we have here the wire sizes. So this is in square mm. So we have the type TW. So TW meaning we have no etch. So the rated temperature rating for this one is 60 degrees Celsius. No etch. Then it could be used in dry and wet location. So we have here the for THHN. So that is 90 degrees Celsius. So for example, if we are going to get the ampacity of a example here, for example, 250 square mm aluminum THHN. So we have 250 square mm. So this is the side for aluminum. This is THHN. So we just align that one, the vertical to the horizontal, 250, and we will have 545 amperes. Okay. So there is also a problem in the internet connection here. So we are going through the same problem now. So I hope you can also replay this video after the discussion later. So after this live stream will end, so you could also replay this video. So let's just proceed. Okay. We will now go to so these are also the application of such wires. We have the low voltage lighting and lamp cords, so that will be 10 amperes for this type of applications. Okay. So electrical wire markings. So wires have markings stamped or printed on the outside sheet of the cable. So these markings tell you what type and the size of wire that you have. So if you have a wire, if you will be looking at the marking of the wire, it will indicate the size and the type of wire. Either it is number 2 square mm, TW, THN. So the marking can be found on the insulation of the wires. Then also we have the wire color coding. So we have here for the black wires. So the black wires are used for the hot wires or the live, the live wires. Also for the red wires, is also used for the hot wires or the live wires, and the switch legs or the switches of our electric fans in 220 installation. Then we have the blue and the yellow wires are also used on hot wires and usually pulled in conduit or usually put in a conduit. Then the white wire or the green and the bare copper wire is used for grounding, grounding wire. So if we are going to use the green wire, we must only install the green wire for the grounding wire or the grounding conductor, Okay. Now also for the neutral, so the color of wire for the neutral is white, The color of wire for the is white. Okay. Okay, let's proceed now to another topic, which is all about outlets and receptacles, Okay. So definition. So an outlet is a point on an electrical system at which current is taken to supply a utilization equipment. So a receptacle is defined as a contact device installed at an outlet or the plug connection of an outlet, or it could take outlet. Now the device put in the outlet or the device installed in an outlet is called a receptacle. So the receptacle is a device. Okay, so you have types of receptacle according to use. So based on the two types of outlets, receptacles basically come into two types. So we have the lighting and the power receptacle. So the power outlets or the power receptacle are further divided to standard receptacle, GFCI receptacles, dryer, and range receptacles. Okay, so first we have the light receptacles, or we all know call this one as lamp holders or lamp sockets. Okay, so these are devices that hold and protect the lamp. So these come in many designs and sizes. So they are classified. So maybe on our previous discussion we have discussed the different types of lamp holders or lamp receptacles. We have the flash, the hanging or weatherproof chain, and the surface type. Now we will go focus now on the power receptacles. So power receptacles are designed to carry heavy current. So these are receptacles. These are as receptacles outlets for utilization equipment like small appliances, ranges, air conditioners, and dryers. So power receptacles usually provides electrical energy or provides power to utilization equipment. So it could be a small appliance, ranges, air conditioning units, and dryers. Okay. So the standard receptacle. So some of us will call this one as convenient outlet, So it is a type of power receptacle which is used as an outlet for regular appliances like TVs, radios, and computers. So these receptacle outlets may accommodate 2 or 3 pin male plug. No? So next we have also the GFCI receptacles. So GFCI receptacles are receptacles which standard use are in bathrooms and kitchens, or any place where there is the area can be wet. So they are reconnaissable because they have 2 narrow slots and a semicircular. Okay, so outlets that are installed into a floor area or to the floor rather than into a wall. So often, a floor outlet will be equipped with a metal plate to protect the outlet and the wiring, along with covers that prevents dust and other material from collecting in the outlet when the device is not in use. So outlets of this type are usually found as well as in conference rooms or other larger gathering areas in offices and public buildings. Okay, so this or a photo of floor outlets. Okay, so as you can see, we have here the covering. No, so for this one, the covering has been removed so that we could attach a male plug. Now for this one, you just push this one so that the floor outlet itself will appear. No, so that you could also attach a male plug on it. Okay, then the weatherproof outlet. So this receptacle outlet is installed outdoors. No, they have also the covering which are waterproof. No, so that if in case the outlet is not used, so they are usually exposed or found on the side of the wall, no, outside the house. So if ever the outlet will be poured in by rain, so it will not go through the outlet itself because the covering of the outlet is weatherproof. Then we have the wall plate covers. So these are just the accessories or the covering of our wiring devices. So aside from receptacles, it also can be used, or it is also part of the switches. No? So this is an example of wall plate cover. So for this one, we have 2 holes here. This is called a 2-gang, no? 2-gang plate cover. For this one, we have a single gang, no? Because there's only 1 hole. So we could have also 3-gang, no? 3 holes. Then for this one, this is the frame itself, which is used to attach the receptacle or the switch, no? And after that one, we could now put here the wall plate cover. Okay. So we have the wall plate box. So it is used when a flash type switch or receptacle will be installed in a surface mounted. No? So this is a wall plate box. Okay, so now we'll be going to switches. No? Switches. Okay. So a switch is a electrical component that cuts, interrupts, or divert the flow of current in an electrical circuit. So in building wiring, a switch, also known as the light switch, is commonly used to connect lights, electrical equipment, or electrical outlet. No? Switches are commonly wall-mounted, but some are inbuilt in with the equipment. Okay. So this is the photo of the first switches, no? Or the first decorative switches. Okay. So we have here the types of switches according to operation. So first we have the hand switches. So these switches are operated by hand. So they are the most common types of switches and are usually used in residential and commercial wiring. Then we have also limit switches. So these switches are operated by machine motion. They are useful in automation and control applications. And process switches, so these are triggered by some changes in physical process. So that's why it is called a process switch. So such processes could be temperature, level, flow, illumination, and others. So like limit switches, they are used for automation and control, especially on industrial plants. So types of hand switches. So first we have the toggle switch. So this type of hand switches is operated by a lever angle in 1 or 2 or more position. So common switches used in lighting system or in lights are the toggle switches. Okay, so these are the examples of toggle switches. Then we have the push button. So this is a type of hand switch which is a two-position which operated by a button that is pressed and released. So push button switches have internal spring mechanism returning to the button to its out or unpressed position for moment operation. So the other term for push button is a momentary switch, meaning if you stop pushing the button, no, it will also release from its press, no, from its press position, and will go back to its initial state, either it is in off state or in on state. Okay, so these are the examples of the push button. So this is the push button usually used in motor controllers. No, this is the push button in an elevator, and we have here the push button on a flashlight. Then we have the selector switch. No, these are actuated with a rotary knob or lever of some sort to select one or more position. So like the toggle switch, selector switches can either rest in any of their positions or contain spring return mechanism for momentary operation. Okay, so these are the examples of a selector switch, no? Okay, so we have for selector switch, we have a pre-selected settings or pre-selected positions, no? For this one, it has 10, no? 10 positions. For this one, we have 2. So this is a selector switch also on motor controllers. So the voltmeter, so we could have the one as off or run or idle or fault, no? Okay, the dimmer switch. The dimmer switch is similar to a select. The dimmer switch is now usually used to control, no, the brightness of a certain lamp. So especially if we are having an installation on a certain bar or a mini bar on the house, no, so we'll use the dimmer switch to control the brightness of the lamp, and also to control the color. So we have also such type of lamp which we could select the color by using a dimmer switch. Okay, so this is an example of a dimmer switch. Then the rocker switch, also known as the seesaw switch, is an off switch that rocks, no? That rocks. So like the music, it rocks. Seesaw, so meaning it acts like a seesaw which has a lever on between of the switch, no? So which means one side of the switch is pressed while the other side is depressed, no? So when you press the other side will move up. If you press the other side, the side which is not pressed will move up, no? And dash line for off on the other to let the user know that if the device is on or off. Okay, so these are the example of a rocker switch. Then we have the slider switch. So it is an of a slider switch. Then we have the types of switch according to configuration.